Ever wondered how electronic systems amplify tiny signals into something useful? That's where operational amplifiers, commonly known as op-amps, come in. What is an op-amp? An operational amplifier is a high-gain electronic voltage amplifier. It has two input terminals and one output. The inputs are called the inverting and non-inverting plus terminals. The key idea is simple. The op-amp amplifies the difference between these two input voltages. Ideal op-amp characteristics. To understand op-amps easily, we often start with the ideal op-amp model, which assumes the following. 1. Infinite open loop gain. That means the op-amp amplifies the difference between its two inputs by an extremely large amount. 2. Infinite input impedance. No current flows into inputs. 3. Zero output impedance. The op-amp can supply output voltage to a load without losing voltage internally. 4. Infinite bandwidth. This means the op-amp can amplify all frequencies equally, from DC to infinitely high frequencies, without signal loss. 5. Infinite slew rate. The output can change instantly with no delay or speed limitation. These assumptions simplify analysis and help us design circuits. The basic operation is as follows. The output voltage is given by V out equals and multiplied by the difference between V positive and V negative. Where is the gain and is very large? Because the gain is so high, even a tiny difference between inputs can drive the output to its maximum or minimum. Open loop vs closed loop. If we use an op-amp without feedback, it operates in open loop mode, which leads to saturation, basically acting like a comparator. To make it useful for amplification, we use negative feedback, creating a closed loop system. This stabilizes the gain and allows precise control. So the negative feedback stabilizes the gain. The most common op-amp configurations are the inverting amplifier. Here, the input is applied to the inverting negative terminal, and the gain becomes equal to negative RF divided by Rin. The second configuration is the non-inverting amplifier. Here, the input is applied to the non-inverting positive terminal. Output is in phase with the input. Here the gain is equal to 1 plus RF divided by Rin. The third configuration is the voltage follower, also called a buffer. Here the output is directly connected to the inverting input. Gain is equal to 1. It is used for impedance matching. Now, we're gonna look at the application of op-amps. Op-amps are everywhere in engineering. 1. Signal amplification audio systems. 2. Filters removing noise from signals. 3. Oscillators wave generation. 4. Comparators decision-making circuits. 5. Instrumentation systems sensors and measurements. Thanks for watching. Don't forget to hit like and subscribe.